Welcome to the VIGG Archive, where knowledge has no boundaries. Today we're exploring helium-3, one of the rarest substances in the solar system. Some scientists believe it could someday help power our civilization with clean fusion energy, while others remain skeptical. Let's take a closer look at what helium-3 is and why it has captured the imagination of scientists worldwide. Helium-3 is a rare isotope of helium. Like ordinary helium, it has two protons, but unlike common helium-4 used in balloons, helium-3 has only one neutron instead of two. That small difference gives it unique properties that make it especially attractive for future fusion reactors. In short, helium-3 is a lightweight cousin of the helium we already know, and that tiny change could someday make a very big difference. Helium-3 is incredibly scarce on Earth. Our planet's atmosphere and magnetic field have shielded us from much of the solar wind that carries helium-3 throughout space. Only tiny amounts are naturally produced here, making it one of the rarest naturally occurring substances on our planet. In fact, the small traces we detect are so minute that collecting it in useful quantities is nearly impossible. This rarity on Earth is exactly why scientists began looking elsewhere. Unlike Earth, the Moon has almost no atmosphere and no global magnetic field. For billions of years, particles from the Sun have struck its surface directly, embedding helium-3 into the lunar soil. Over time, the Moon's dusty surface has acted like a giant sponge, soaking up these solar particles. Scientists believe that the trapped helium-3 could someday become one of the Moon's most valuable natural resources. The excitement surrounding helium-3 comes from nuclear fusion. Fusion is the same process that powers the sun. If scientists can successfully harness helium-3 for fusion, it could produce enormous amounts of energy with far less radioactive waste than many current nuclear technologies. This is why helium-3 is sometimes called the fuel of the future. It promises clean, abundant energy, at least in theory. Of course, there's a major challenge. Fusion is extremely difficult. To make helium-3 fusion work, scientists would need temperatures even hotter than the center of the sun. Although experimental reactors have made important progress, no commercial helium-3 power plant exists today. The technology is promising, but we're still in the experimental stage. The dream is alive, but the engineering is incredibly hard. Even if we solve fusion, getting the fuel presents another challenge. To extract helium-3, we need to mine enormous amounts of lunar soil, heat it to high temperatures, and carefully collect the tiny amount of gas released. This would require advanced robots, massive equipment, and long-term industrial operations on the Moon. It's not just a science project. It would be one of the largest engineering and logistical undertakings in human history. Many nations are now planning long-term missions back to the Moon. NASA, China, and even private companies all have eyes on a permanent lunar presence. While science is the main goal today, valuable resources like water ice and possibly helium-3 are becoming part of the conversation. Some experts imagine future lunar bases that could support mining operations decades from now. Not everyone is convinced. Some scientists believe helium-3 could revolutionize clean energy and change civilization forever. Others argue that mining the Moon and building helium-3 fusion reactors may prove too difficult or too expensive. It's a debate between bold optimism and practical skepticism. Only future discoveries and technological breakthroughs will answer the question. For now, helium-3 remains one of science's greatest what-ifs. Whether helium-3 becomes the fuel of tomorrow or remains an ambitious dream, it reminds us that the Moon still holds many mysteries. Thank you for watching the VIGG Archive. If you enjoyed this presentation, please like, subscribe, and join us again as we explore history, science, literature, and the remarkable ideas shaping our world. Until next time, Keep asking questions and keep exploring.